All right, so today we're working through least common multiple. We've learned GCF, and like we just talked about, LCM is just one more step after we find the GCF. All right, so let's look at example 1 now. Okay, there's two ways that I can find LCM. The first one is by listing multiples, and the second way is by doing the prime factorization. All right, so I have the numbers 8 and 20. And when I say listing multiples, I'm not talking about the factors, okay? Now, the factors of 20, what would be some factors of 20? Just tell me. It would be 1, 2, 4, 5, 10, okay? Those are factors. When I'm talking about multiples, that's not a factor. That's the opposite. Multiples, I'm essentially multiplying the number and I'm adding the same amount. So if it's 20, I'm going 20. What's my next multiple of 20? 40, 60, 80. Those are my multiples, okay? So in order to find LCM by listing multiples, here's what I want you to do. I want you to start off with your largest number, which is 20. Now, does 8 go into 20? No, so I need to keep going, okay? 8 does not go into 20. All right, what's the next multiple? 40. Does 8 go into 40?
Yes.
Yes, it does. Now I know where it ends. Now I know my LCM. Now I just fill in my numbers, my multiples of 8, and I know what to go up to. Okay? I circle 40 as my LCM, and I label it as my LCM. Hold on, sorry. All right, so now I want you to try one. Okay? I want you to do 4 and 15. Okay, list your multiples, start with your larger number. Once you find that number, then go ahead and just list out your multiples and tell me what the LCM is. All right, so let's go by 15s. Does 4 go into 15? Nope. Does 4 go into 30? Nope. Does 4 go into 45? And what about 60?
Yes.
All right, so now that I know it's 60, I just list my multiples of 4 till I get to 60, circle it, and write it as my LCM. Who got it right? LCM is 60. All right, good job. Okay, so now let's shift gears over now to the next example, and that's finding, oh, hold on. We need to do one more. Sorry, we have to find it with 3 numbers. Okay, so now finding LCM by listing multiples when I have more than 2 numbers, 3 numbers. Okay, so what number do you think you'll start with?
12.
12, right? Okay, so go ahead and start listing your multiples of 12. Okay, so I have 12. What comes next? 24. Oh, great. 8 goes into 24. So that's my LCM. No, because 5 doesn't go into 24. They all have to go into it, so I have to keep going. 36, 48, 60. Oh, great. 5 goes into 60. But 8 doesn't. 8 doesn't, so I have to keep going. All right, so 72, 84. I have to keep going till I have a number that ends in a 0 or 5 at least. Okay, now I'm at 120. Okay, well I know it ends in a 0, so 5 can go into it. Now let's test it in our calculators. Can 8 go into 120 evenly? Very good. It does. So since 5 and 8 both go into 120 evenly, I know that 120 is my LCM. And now it's just a matter of filling in my other multiples. Okay, so for 8, I fill them all in. On your notes, you don't have to do this. Just know that on your homework tonight, you do need to fill in those multiples. I know that it can get tedious with some of our larger numbers, but I need you to do it just for the practice. Okay, that's why I didn't give you very many problems for homework tonight. Only 7 for homework tonight. All right, so now let's shift gears over to the prime factorization. Okay, so hopefully by now, prime factorization is getting to be pretty automatic. I want you to go ahead and do the prime factorization for 144 and 156 and list out your prime factors. All right, so working through the upside down division, make sure you're dividing by what kind of numbers? What kind of numbers do you have to divide by? Prime numbers. Prime numbers. Okay, check your prime factorization. Does it match mine? Yeah. 4 2s and 2 3s for 144, and 2 2s, a 3, and a 13 for 156. Now what do I do? What do I do now? LCM. I need to, well, how do I do the LCM? I need to, I've got to pair them up, right? So let's go ahead and pair up. I've got a couple pairs of 2s and a pair of 3s. So I write for each pair, how many times do I write it in my LCM?
1, 2.
For each pair, I write the number 1 time in my LCM. 2 times 2 times 3. But I'm not done yet. Actually, while we're thinking about it, what's our GCF?
12.
Our GCF is 12. Very good. Because this is where it ends for GCF. But we know with LCM, we have to bring in our leftover numbers. So times 2 times 2 times 3 times 13. And what's my LCM?
Oh, I got 936.
No. Starts with a 1. 1,872. Guys, this is the easy part where you just plug it in your calculator. So please don't make a mistake there. All right, so that's how you do LCM through prime factorization. Now, it's a little different, and I need you to pay very close attention. It's a little different now. Here's where we have an exception to the rule. When we are doing the prime factorization, this is where it's going to differ a little bit from GCF. When we're doing the LCM through prime factorization of 3 or more numbers. So I want you to start by doing the prime factorization of these 3 numbers and listing out your prime factors. All right, so for 55, that one's short. 88 was a few more factors. 220, I've got a couple. So you should have listed them out. Double check your prime factors to make sure you didn't miss anything. Okay, so do you have them? 5 and 11 for 55, 3 2s and 11 for 88, and 2 2s, a 5 and 11 for 220. Okay, so now let's talk about if we were finding GCF. If we're finding GCF, the factor has to be in only 1, only 2. It has to be in all 3 to count. So what is the only number that would count as a group for GCF? It's 11. Now here's where LCM is a little different. For LCM, the factor only has to be in 2 of the numbers in order for it to count as a group. That even means if you're finding LCM of 4 numbers, it only has to be in 2 of the numbers to count as a pair. So while 11 is still in all 3 numbers and I still circle all 3, that is not the only group that I can circle for my LCM. What's another group I could circle? Larry? I could circle my 5s because I have a 5 and 55 and a 5 and 220. I only have to have 2, so that counts as a group. Any other numbers count as a group? I've got a group of 2s. Do I have another group of 2s? Very good. So again, for each group, how many times do I write it in my LCM? 1 time in my LCM. So 2 times 2 times 5 times 11. But now do I have any leftover numbers? I have the leftover number 2. And now I multiply them all together to find my LCM. Okay, so put them in your calculators. All right, guys, what is it? 440. Very good. Okay, so to find LCM, guys, of more than 2 numbers, I'm going to say it one more time. You listening? You listening? It only has to be in 2 of the numbers, the factor, in order for it to count as a group. And then I write it 1 time in my LCM. This might be the part of the video that you want to go back and rewatch when you're doing your homework tonight or studying for your quiz. Okay, but that's up to you. If you're struggling with it, use the video for some extra help. If you understand that, that's everything you need to know for 4.4.